right, so talk about overcomplicating things. Your book goes way overboard with this whole dilution stuff. So I'm just going to break it down pretty simply for you because I don't really want you to have to go through all the orange juice stuff that they did. Basically, when you're diluting something, you're just adding water to it, right? So the number of moles of the substance, the actual powder, so to speak, is the same. It's just that you've changed the concentration of it. So imagine if you're, some of you must have made juice or hot chocolate or anything that comes from a powder, and you put too much water in it and it's diluted. It tastes not strong enough, right? So if I put a teaspoon of hot chocolate powder in a cup and I fill it up with hot water, I'm going to be like, oh God, this is not good enough. But if I take that same teaspoon and I only fill the cup up like, well, okay, you maybe half, me like a quarter of the way, then that hot chocolate's going to taste a lot better because it's a lot stronger, right? So what we're basically talking about here is it's the amount of dilution that tells you what the concentration is, but the moles, the number of actual particles, is still the same no matter how much water you add to it. So, that being said, the way that we say that in chemistry is that the moles in the concentrated form are going to be equal to the moles in the diluted form. And when your book's talking about moles, remember it used this part where it just says moles are N. So the number of moles, they just use N. And I talked before about how molarity is moles over liters. And your book uses concentration is the number of moles over the volume. So to me, it's a little redundant because if you just follow the units, you're still going to go through all this stuff. But because your book addresses it this way, I'm going to explain it the way that they do. So if the number of moles before I diluted it, concentrated, is equal to the number of moles after I diluted it, because really all I did was add water to it, then I can say that I can put this in my little triangle, and I can go N is on the top, C is here, V is here. So N is equal to C times V. So that's where they get this. They say, okay, the diluted concentration times volume gives me the number of moles. Concentration times volume gives me the number of moles. So they use this little simplified formula because what they want to do is manipulate it for whatever they're asking for. So in the example on page 101, they have 200 milliliters of 0.500 m of sodium chloride, and it's added to 300 mils of water. So this is the sodium chloride, and then they added it to, and I'm just going to put it up here, 300 mils of water. Now water is just the dilution, so we're not worried about that. What we want to look at here is what did they give us? So they gave us the volume of the concentrated one, because the concentrated one's the before diluted one, right? You could call it the initial one and the final one, I don't care. But they're saying the concentrated volume was 200 mils before it was diluted, and the concentration before it was diluted is 0.5 m. So they're asking us for the resulting concentration of the mixture. So they're asking for the diluted concentration of the mixture. You can use your own letters if you don't like theirs. I don't care. It's just the pattern. So this one then must be the volume, but wait, it's the volume that was added. So we can't say that it's the final volume because there was already 200 mils. So to find the final volume or the diluted volume, we would have to go, there's 200 mils to start with, we added the 300 mils, so now we have 500 mils in total. Don't be jumping off here, buddy, I need you. So I want the diluted concentration, I have all the other things. What I'm going to do is combine them using this formula, but I need to isolate for this variable, for the CD. So this is CD times VD equals all that. So if this is being multiplied then, I'm going to change my formula around, put it on the other side, and divide it. Like that. So now I've arranged my formula so that it's what I want is by itself, and I can just throw in the numbers. So I'm going to throw in 0.5. I'm going to throw in 200. It doesn't matter if it's in mils or liters, just make sure that the units agree. So if I'm putting it in mils on the top, I better put it in mils on the bottom. So on the bottom, it's the volume that's diluted, which is these guys added up. So that's 500. So now I'm going to go 0.5, which is a half, times 200 gives me 100 over 500 is 1/5 equals 0.2. You could use your calculator. So the concentrated, or the concentration of the diluted, the final amount, is 0.2 moles per liter.